My name is Ajinkya. I'm working with Rightmove as a backend engineer on Find team. And today I'll be talking about how we are using Elastic for our property search and property alert use cases. Uh, so first and foremost, let's look at who are Rightmove, what we do. Uh, so Rightmove, if you have probably used in the past, if you're looking for the properties, maybe you have been on our website. It's one of the biggest property portal in the UK. A primary aim uh, is to allow users to find the properties, and is to allow estate agents to advertise their stock on the web portal. So uh, we have around 55 million visits a day, which makes us one of the busiest websites in the UK, and we have around 1 million properties on stock. So which is not surprising because UK property market is quite hot, right? So uh, ever since Elastic was introduced at Rightmove, we use it for multiple purposes. One of the most important one is the property search. So as I said, our primary aim is to allow users to find the properties as quickly as possible. Uh, Elastic helps us great deal with this property search use case. Then we have sold property search and analysis, where we get the property data from like the sold property history data from uh, uh, the land registry, and then we check it into the Elastic index, and then we build a tool on top of it to find that out, to find the sold property history. So if you want to look for history of particular property in particular area, you can just use our tool and find the sold transactions on that. Uh, Another one is the property alerts. So if you want to look for any property and you want to know whenever the new property comes into the market, you want to be alerted, you can use a property alert feature. We also use Elastic for giving the meaningful suggestions to the user whenever they are looking for the properties. You start typing the location, and we give the list of locations which help users so that they don't need to type the entire location. Uh, and last but not the least, and I think it's one of the most common use case for Elastic, is to support the site and our applications using ELK stack, the Elastic Kibana and Logstash stack. Uh, so we use it as well. We have at Rightmove, we use microservices, and all our microservices are configured to send their logs and send the metrics data to Elastic cluster. This separate cluster for the one from the one we use for search, because we don't want amount of logs we generate to hamper performance of our search. So we also started using Elastic APM, which is a feature that Elastic provides to get the insight into the JVM. You can look into how much memory is getting consumed, how much CPU utilization is there, how many threads are spawned for the JVM, etc. So that's also one of the things we are using. In today's talk, I'll be focusing on the property search and property alerts. So let's start with the property search. So ever since Elastic was introduced, we have used it for property search because uh, it's very easy to index the data in Elastic. Like, it's quite fast to add new properties in Elastic. It's quite fast to search the properties on Elastic by using various queries. Specifically, we are using geo queries because if you think about the Rightmove use case, whenever you are looking for the property, you are always looking for a property in certain region. So all our queries are necessarily the geo query. So we wanted something which can provide good geo capabilities as well as provide good search capabilities, the quick searches through millions of properties. Because as I said, we have around 1 billion properties available on the site at this point in time, which is usually the average. So that's why we are using Elastic for property search. Let's look into the flow. So one on the left hand side is, sorry, this is right now. So one on the right hand side is the user properties. So whenever user wants to search for the property, they can use our mobile app or the website, and then they put all the filters that we have provided to make the specific searches for the property in the specific region. And the request will come into the property web, which is one of our web service, one of our microservice that we use. To keep the thing simple, I haven't given all the details about what kind of architecture, microservice architecture we're using. But essentially, the apps requests are handled by different microservice. So even though this calls property web, it only handles the web request, but essentially it's doing the same. Like the app service is also doing the same. So user enters the location and user enters all the search criteria. They come into property web. Now, property web needs to identify the exact geometry of the location, because if you just say, hey, give me the properties at Tottenham Court Road, Elastic is not going to understand that, right? So you need to have the exact geometry so that we can make the geo search. And that's where it calls the service called UK location. So we store all our location data in Oracle, and UK location service comes. Thanks. So UK location service comes into picture for giving the location data to property web. Property web gets that data and sends it to property search. Property search is the service, you can think of it as a REST API and built on top of Elastic. It handles all the concerns related to Elastic, so that if any changes happening, if any version updates happen, all the other services are not impacted. We just need to change one place and then we're good to go. So gets all the data. This is the service which knows how to talk to Elastic. So it converts that into the query that Elastic understands and then sends the query to Elastic. Elastic does its magic. It finds the properties and then results go all the way back to the user on app or on the website. That was about how to extract data from Elastic. But to extract the data needs to be there in Elastic, right? So that's where this part of the diagram comes in. So as you might have already figured out that we are not using Elastic as a primary source of truth. So our primary source of truth is Oracle. So we need some kind of mechanism to get the data from Oracle, and then put it in Elastic. So when a new property comes in on Oracle, when an agent uploads a property that comes in our Oracle database, it goes to Kafka queue. Now, Kafka is the messaging system we are using, but you can use anything for the purpose. Essentially, it comes to queue. Property search service is listening to the queue. It gets all the update events, update, delete, or add events on the property, and then creates an indexable document out of it and indexes it in Elasticsearch. That was about the architecture. Now let's see how we are using some of the geo capabilities of Elastic. Before that, I'll just walk you through all the filters we have. The most important one I have tried to highlight there is the location, because we'll be using, like, all our queries essentially have location part in it. So we have location, and we have quite few other features, like you can select how many bedrooms you want, what kind of price range you're looking for, what kind of features you want from the property. So all of these filters user puts in on the website and then hit the search button. That's where the Elastic comes in. So as I said, all our properties are related to the location. We need to have some kind of a mechanism to save the location data so that it can be queried later, right? So let's see how Elastic comes into picture and what kind of features Elastic provides to save location. So Elastic has two types of fields on the document: Geo Point and Geo Shape. You can use either one of them. We are using both. So I've just taken the snap from our property index, and as you can see, it has both the fields, because some of the Elastic queries in the previous versions used to only support one of them. So Geo Distance queries, which I'll be talking about, used to only support Geo Point, but in the latest versions of Elastic, all the queries all the fields are supported. So you don't necessarily need to have both, but due to historic reasons, we have both. This is what the document actually looks like. So as location field is the point, we have lat and long. As shape field is as position field is the shape, we have coordinates. So it takes the array of coordinates. So you can essentially save the property as a polygon as well, which will be the small array of a small closed polygon. Now let's look at how to query this data using geo capabilities. So some of the I'm going to talk about three most important queries that you use. So first one up is the geo distance query. Geo distance is the one we use whenever we want to find some data around particular point. So in our use case, let's say if user wants to find the properties in certain train station, because the commute is very easy, probably the train station, or user wants to find let's say if you are just taking a walk and you like the area, you want to find out what kind of properties are available in that area, then you can use our current location search from apps, and then that turns out into the geo distance query. So anytime whenever there is a point and you want to search something around the point, that's where the geo distance query comes in. Let's look at the actual query. So since geo distance query takes a point, it's taking the location as an input and also the distance around point. Now this one is 804 meters, which is half a mile, but you can specify 1 mile, 1 kilometer, like that, like those kind of units as well. Elastic has documentation available about what kind of unit it accepts. One important thing to note here is we are using Geo JSON format here, and that's where the longitude and latitudes are flipped. Now this has caught me quite a few times when I started working on it, because I'm always used to say latitude and longitude. I'm used to that convention, but GeoJSON needs expects you to send the longitude first and latitude later. So I thought it's worth mentioning. Just keep that in mind. Then next one is the Geo Shape queries. So this is probably one of the most used queries at Rightmove, because essentially when you're looking for the properties, you're looking at certain area, and that area is not going to be certain point and circle around it, right? It's going to be area of various shapes. So that's where Geo Shape queries comes in. It accepts polygons as input and then gives you all the properties within that polygon. So as you can see here, I've taken a snap from the search on the Kensington area in London, and it doesn't have, it has the polygon with multiple vertices. So one thing to keep in mind when you're using Geo Shape queries is the performance of the query is not related to how big the area you're scanning. It's dependent on how complex the structure of area is. So how many vertices are involved in the polygon that you're inputting. The performance is directly dependent on that. So if you can look for any opportunities to simplify the polygon, then do leverage that, because in our case we are using maximum difference algorithm, similar to Douglas Bucher algorithm, to simplify the area. So yeah, that's something to keep in mind. This is the example of Geo search, so Geo Shape search. So the filter type is Geo Shape search. The position is the name of the field, and shape is the GeoJSON, the region expressed as GeoJSON. One more important point to note here is the first and last coordinate is same. That is because the polygon has to be closed. Elastic is not doing that directly for us. So we have to make sure that the first and last point of the region, of the shape that we're inputting, has to be same. And next one is the geo bounding box. So this is where Elastic gives you an ability to search within the rectangle. Now, when I first heard about it, it didn't make sense to me, because when you're searching for something on the map, you're not looking at area as simple as rectangle, right? But if you look at the actual use case, then the area that we are searching for, like the devices that we are using to search the area, are actually rectangular shape. All the viewports of the devices are rectangles. So in this case, if you can see here, this is the snap I've taken from the app. If user clicks the search here button, essentially what he's doing is he's just interested in all the properties within this rectangle. So if you come across these kind of scenarios, it's always better to use geo bounding box queries, because they are way faster, right? Because a rectangle has only 4 vertices, and then it has the horizontal vertical line, so it's pretty easy to search within the rectangle than using some geo shape query. Let's look at actual query. It's similar to the previous one. The filter type is Geo Bounding box, but the only difference is you don't have to specify all the four vertices of rectangle because you can just specify top left and bottom right, and then Elastic can figure out the entire rectangle for you. Yeah, that was about Geo Bounding box. I've got quite a lot of details here, so I'll just summarize. Use Geo Shapes whenever you are searching within the polygon, but keep in mind that Geo Shapes are expensive. Use Geo Distance when you have certain point of interest and you want to search around certain point of interest. Use Geo Bounding box when you know that you are searching within the user's viewport, you are searching within the rectangle. Some of the things I thought I will be worth sharing. Some of the things that we have done to optimize the Geo Shape queries that we use is look for any opportunities where you can reduce the number of vertices. For example, in this snap, user had searched originally for the entire region, but then they are zoomed in, so only part of the region is visible now on the viewport. So we can make GeoShape query again, the previous one that we used for the entire region, and then hide the properties. But that will be extra processing. Instead of that, we can specify these three parts of the region using three vertices, and then that will reduce the number of vertices we are sending. So look for all these opportunities where you are where you can optimize the GeoShape queries. And last but not the least, and I think it's one of the most important thing is don't use GeoShape queries because it's just a tool that is easy to use. Find an opportunities where you can completely avoid using GeoShape. We have found one opportunity where we can avoid it in case of postcode search. So if user tries to find out something within the postcode, then we can actually find out the area for that postcode and send the GeoShape query. But instead, we can also index the postcode whenever we are saving the property, and then make the text search instead of doing the GeoShape. So that look, all I'm trying to say is look for the opportunities like this, and then try to optimize it. Yeah, that was about the GeoShapes. Now let's talk about property alerts. Property alerts is when user wants to search for certain properties. If you want to buy a house, it's not necessary that you go to Rightmove or enter all the filter criteria, hit the button, find a property, go to agent and buy it, right? It's not that simple. So we are always interested in finding out what is new on the market, and that's where the property alerts comes in. Whenever we get any new property on the market and that property matches your search criteria, we send an email alert. So let's see how we enable it on the UI. So in this case, I have taken the example of West London. I'm trying to find a one bed property in West London. Then I hit the save search. And hit the I save the search, and then it gives me an option to create an alert. Now we have various frequencies you can set on the alert. Can be weekly, it can be 3 days, it can be 7 days. Depends on how frequently you want to get the alerts. And this is how the alert will look like. So in this case, there are 2 new properties which are available and matching my criteria, so I received an email. Let's see how we do it in the background, and let's see how Elastic helps us achieving this. So property alerts was one of the complex use case because we want to alert users as quickly as possible as and when property comes in. And we have a lot of property alerts saved because I think it's one of the very useful features. As you can see the numbers, we are around 5.8 million saved searches, and we generate around 3.5 million alerts every day. So to achieve this, we wanted some kind of a way to quickly go through the alerts and then generate the matches. And that's where Elastic's Percolators comes into picture. So Percolator is kind of a reverse search where Elastic allows you to index the actual queries that we are going to use to find out the documents. So let's say if you have certain search criteria, we save that entire search criteria as a document in Elastic, and when a new property comes in, then we run the query against the saved search criteria, like the saved search criteria index, and find out whether the property matches the query instead of query matching the property. which is like a reverse thing. So I already mentioned some numbers. We have around 5.8 million saved searches, 3.5 million alerts, and 2 million locations. I'll come to the location part in a bit, but let's first look at how the Percolator index looks like. So this is the snap I've taken from the PAL saved search index. PAL stands for property alerts, and the important point to note here is the type of the query field, which is Percolator. So in this query field, we can actually save the query that user is trying to make. In this case, it's a saved search criteria. Don't get confused by the name of the field. Name of the field is query. You can give any other name. We chose query because we are actually saving the query. And this is how the saved query will look like. So as you can see, this is the bull filter term. The user is trying to find out the property which has parking, and user has saved the criteria. Whenever they save it, this kind of query is saved in the Elastic index. Along with that, we are also saving some metadata, but I'll come back to that later. So now we have saved the query in Elastic, right? And new property comes to market. What happens behind the scenes is we run the query against, we run query against the index which has queries. I mean, it's a bit confusing, right? So PAL saved search index has saved queries, and then we are trying to run the new property. In this case, the property document is having parking. So probably we should find a match. Important point to note here is the type of filter, which is Percolate. Name of the field is query, and the document contains array of the document. We are just using one document because we are doing it for each and every property that comes in. So in this case, we should be able to find a match ideally. And whenever the match is found, we get this kind of response, which gives you the details about what is the ID, which we then use to find out who the user for this saved search is, and then alert that. Yeah, so far so good, but things become difficult as you do them at scale, right? So same is the case with Percolators as well. The Percolator is essentially a query that is saved, and then whenever a new document comes in, you're trying to run that against each and every query. Now, if you think about our use case, we have 5.8 million searches, and we start running every property that comes to market against 5.8 million queries. That's not going to be a good. I mean, Elastic cluster will not be happy with us, right? So we try to do some optimizations, and whenever it comes to optimizations, we always find what is the strongest case of Elastic. The strongest point of Elastic is doing the text searches, right? So why not use text search and then filter down the number of Percolator queries that we are trying to match against, and then actually do the Percolator queries. So we use two kind of filters here. One is on the transaction type, which can be buy or rent, because that broadly separates two types of saved searches for us, because anybody who is looking to buy probably will not save search and will not be interested in getting alerted on renting properties which are available to rent, right? So that kind of divides it by a significant chunk. And then we use location key, which again filters it down from maybe from millions to thousands, because instead of running the queries against each and every location, each and every saved search, which is of type buy or rent, because we already filtered based on buy or rent. We only run the queries against the saved searches which are specific to that area. So when your new property will come in, we find what is the address of the property, and then we find what is the location in our saved location index. So I'll explain it on the next slide. But this is how the saved search document looks like, and this is the part which we are using for filtering down the percolators even further. So there's a metadata part. It has transaction type and it has location type. I'll come to location in the next slide. And we also have saved search ID and user ID to identify which user to be alerted whenever this saved search match is found. So yeah, when your new property comes in, as I said, Oracle is a primary source of truth. So property comes to Oracle, then it lands in Kafka, because by now you must have figured out without Kafka. So it goes to Kafka. User property feed is a service which listens from Kafka, and instead of directly hitting the percolator query, it first tries to find out whether it can do the location based optimization. So it finds out with the location that property has is matching with any of the existing locations that we have on the location index. If it finds the match, then it gets all those location keys and creates a query for using the term filters that I shown you in the last slide. So using transaction type and location type, and then makes actual percolator query. So if it finds the match, then it goes back to user property feed. The property feed creates a document in the Couchbase with the user details and what is the saved search ID for that user, and which is then picked up by another microservice to actually send an alert. So yeah, that was about the alerts, and that was actually everything I wanted to cover. So thanks for listening to me, and if you have any questions, then don't hesitate to ask.
Maybe the question is too complicated, so feel free not to ask.
I try.
When you have a complicated shape, and when I'm saying complicated, we're talking on a very small area, let's say Singapore, and you have a very small area in it, obviously. And the shape is like that. So it's going like that, and actually it matches something that is outside the area, the shape.
Yeah.
But it's, I mean, if you make not so complicated area, it's actually won't get in.
Yeah. So if you have like star-like structure or something,
and sometimes depends on how precise you want to do the search. It could get in. It could say, yeah, it is in this area, but it's actually not. Have you ever encountered such problem?
Yeah. So in this case, Elastic. Let me go back to the query, which is actually a good question because I somehow forgot to cover that part of the query, I believe. Is the relation. So Elastic provides you the option of relation, where in this case we are using within. Within means find all the properties which are exactly within this region. And then there are other options as well, like disjoint or intersect, where you can find the properties which are not in this region, or which are just crossing over this region. So it's like that. And then whenever we are simplifying the stuff, we always make sure that we are not oversimplifying it, and that's where the precision part comes into picture. Does that answer your question?
Yeah. Maybe. Yeah.
Yeah. Thanks. Yeah.
Hi. Yeah. First of all, like, great presentation. And a lot of useful information. I just wanted to. I was curious. I'm not sure if you know this, but when you say that the Geo Shape queries are more expensive than the Geo Box, for example, how much more expensive would you say? I guess it depends on the polygon shape as well, right?
Yeah, it depends on how many vertices are involved in the polygon. So I haven't actually done the stats on how much the Geo Bounding box takes versus how much Geo Shape takes, but I'm pretty sure that they are pretty fast when you use Geo Bounding box.
Right. Thank you.
Yeah, it'd be interesting running some numbers.
Yeah.
Bounding box and Geo Shape. I don't know.
Yeah.
Yeah, and yeah, it would be very interesting to see like the difference between the two, especially depending on the number of the polygon
What is
size
this?
as well. Yeah, but
Yeah.
That would be interesting. Yeah, thanks a lot.
Yes.
Any last questions? Cool. Well, can I say thank you again?
Thanks.